Aberdeen Proving Ground, Maryland, November 17, 1943. German engineering officers stood in a spotless American testing facility, their captured Type 82 Kübelwagen positioned beside an American Willys MB Jeep. They had been brought here as technical advisors, prisoners of war with specialized knowledge that American intelligence deemed valuable. What they witnessed in the next hour would dismantle every assumption German military engineers held about vehicle design philosophy. The American testing officer gestured toward both vehicles. Specifications had already been distributed. The German officers examined the documents with professional skepticism. The Willys MB, 2,453 pounds empty weight. Payload capacity is 800 pounds. Maximum speed 65 miles per hour. Four-wheel drive, 60 horsepower engine. The numbers seemed impossible. Their own Kübelwagen weighed 1,600 pounds empty, produced 23.5 horsepower from its air-cooled engine, and achieved 50 miles per hour maximum. It had no four-wheel drive, relying instead on clever engineering, a locking differential, and extraordinarily light weight. German military doctrine had emphasized these qualities: efficiency, fuel economy, ease of field repair. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. The American demonstration began simply. Both vehicles were loaded with 800 pounds of sandbags. The Kübelwagen sagged noticeably under the load. Its lightweight construction, designed for 4 soldiers and minimal equipment, struggled with the weight distribution. The American Jeep absorbed the load with barely perceptible change in its stance. Its suspension system, heavier and more robust than German designs, maintained ground clearance and stability. The convoy of test vehicles moved to the rough terrain course. Here, American engineers had constructed obstacles that simulated battlefield conditions: steep inclines, muddy trenches, rocky surfaces, water crossings. The German officers had seen similar testing grounds in Germany. What they had not seen was the systematic, documented approach Americans applied to every test. The Kübelwagen went first. Unladen, it performed admirably. Its light weight allowed it to traverse soft ground without sinking. The rear-mounted engine provided excellent traction on inclines. When stuck, 4 men could physically lift and reposition the vehicle, a design feature German engineers considered essential for battlefield utility. With 800 pounds loaded, performance degraded dramatically. The vehicle struggled on moderate inclines. Traction suffered in mud. The two-wheel drive system, adequate for reconnaissance missions with minimal equipment, proved insufficient for sustained cargo transport under combat conditions. The American Jeep followed. With 800 pounds loaded, it climbed inclines the empty Kübelwagen had barely managed. The four-wheel drive system delivered power to whichever wheels maintained traction. The heavier construction, which German engineers had initially dismissed as wasteful, provided stability that prevented the vehicle from becoming stuck in the first place. The performance gap was undeniable. German engineering philosophy had prioritized weight reduction above nearly everything else. Lighter vehicles consumed less fuel. They required smaller engines. They could be manufactured with less steel, less rubber, fewer resources. In a resource-constrained economy preparing for prolonged war, this logic was sound. What German planners had not adequately considered was operational capability under sustained load. The testing officer explained American design priorities through an interpreter. The United States Army had specified that every tactical vehicle must operate effectively when fully loaded with combat equipment, not merely when carrying soldiers. Infantry units required vehicles that could haul ammunition, rations, water, communications, equipment, weapons, and wounded personnel simultaneously. The 800-pound payload specification was not aspirational. It was minimum acceptable performance. German doctrine approached logistics differently. Light reconnaissance vehicles like the Kübelwagen were intended for officers, scouts, and liaison duties. Heavy cargo moved via trucks or horse-drawn wagons. This division of labor made sense when motor vehicles were scarce and expensive. American military planning assumed abundant vehicles. Every unit, down to platoon level, would have motorized transport. This assumption fundamentally altered design requirements. The next test measured top speed while loaded. The Kübelwagen, with 800 pounds aboard, achieved 37 miles per hour on level paved road. The strain on the engine was audible. The vehicle was operating beyond its designed capacity. The American Jeep maintained 55 miles per hour with the same load. Its larger engine, producing more than twice the Kübelwagen's horsepower, had power reserves even under full load. German officers made calculations in notebooks: fuel consumption per mile while loaded, time required to move cargo over typical battlefield distances. The mathematics revealed uncomfortable truths. Yes, the Kübelwagen consumed less fuel per mile when lightly loaded, but moving equivalent cargo required either multiple trips or multiple vehicles. Either way, total fuel consumption exceeded what the heavier, more powerful American vehicle required for a single trip. This represented a fundamental difference in engineering philosophy. German engineers had optimized for component efficiency. American engineers had optimized for mission effectiveness. The distinction seemed subtle, but produced dramatically different vehicles. The testing continued with reliability assessments. Both vehicles were subjected to extended operation on rough courses, simulating continuous battlefield use. Maintenance requirements were documented meticulously. The Kübelwagen required frequent adjustments due to its lightweight construction. Vibration loosened bolts. Rough terrain stressed components designed with minimal safety margins. Field repairs were simple, exactly as German engineers intended, but they were frequent. The American Jeep required less frequent maintenance. Its heavier construction and conservative engineering margins meant components operated well within their stress limits. When maintenance was necessary, American procedures emphasized replacement of entire assemblies rather than field repair of individual components. German officers found this approach wasteful. Why replace a functioning transmission when repairing the damaged gear was possible? The American testing officer explained the logic. In combat, time was more valuable than components. A vehicle disabled for 2 days, while a mechanic performed intricate repairs, represented greater loss than replacing an entire transmission in 2 hours and returning the vehicle to service. Parts were abundant. Trained mechanics were not. Skilled labor should focus on keeping maximum vehicles operational, not on performing complex repairs that minimized parts consumption. This philosophy permeated American military logistics. Standardization enabled interchangeable parts. Mass production ensured abundant supply. Simplified maintenance procedures allowed soldiers with minimal training to perform most service tasks. The system prioritized operational readiness over resource conservation. German officers observed American mechanics performing Jeep maintenance. The technical manual provided step-by-step instructions for every procedure. Mechanics followed documented processes, rather than relying on experience and judgment. Torque specifications for every bolt were listed. Diagnostic procedures used decision trees that guided mechanics through problem identification without requiring deep technical knowledge. This systematization troubled German engineers philosophically. Their training emphasized understanding vehicle systems holistically. A skilled German mechanic understood why components functioned as they did and could diagnose problems through analysis and experience. American procedures seemed to assume mechanics lacked this knowledge, providing instead algorithmic instructions that anyone could follow. The American approach was not intellectual laziness. It was recognition that modern warfare consumed skilled personnel rapidly. Casualties, reassignments, and unit expansions meant experienced mechanics were constantly depleted. A logistics system dependent on highly skilled individuals would collapse under combat attrition. A system based on documented procedures and interchangeable personnel remained functional regardless of personnel turnover. The testing officer demonstrated this principle directly. He called forward a soldier who had completed basic mechanical training just 6 weeks earlier. Using only the technical manual, this soldier performed a complete engine replacement on a Jeep. The task required 4 hours. An experienced German mechanic could have done it faster, but that experienced mechanic represented years of training and irreplaceable expertise. The American system had traded individual excellence for systematic reliability. German officers discussed these observations among themselves during breaks. Their conversations revealed deep unease. Not because American vehicles were superior in every measurable way, though that was true for payload and speed. The unease stemmed from recognition that American military philosophy was fundamentally different. Germany had built an army that depended on skill, experience, and improvisation. America was building an army that depended on systems, procedures, and abundant material. The implications extended far beyond vehicle design. If American forces could achieve battlefield effectiveness through systematic organization and material abundance, rather than individual skill, they could sustain combat operations indefinitely. Personnel losses could be replaced with minimally trained soldiers who followed documented procedures. Equipment losses could be replaced from production lines that exceeded anything Germany could match. One German officer, an engineering colonel who had supervised vehicle development for an infantry division, made a bitter observation. The Americans had mechanized warfare itself. They had reduced combat to a series of systematic processes that could be executed by ordinary soldiers using standardized equipment and documented procedures. The Wehrmacht's emphasis on tactical excellence and operational artistry suddenly seemed like 19th-century warfare attempting to compete against industrial process. The testing continued for 3 more days. Every aspect of vehicle performance was measured, documented, and compared. Acceleration times, braking distances, turning radius, fording depth, obstacle clearance, winch capacity, towing capability. In nearly every category, the American Jeep exceeded Kübelwagen performance. Where the German vehicle excelled in fuel economy and ease of field repair, those advantages proved less significant than German doctrine assumed. The final test examined cold weather performance. Both vehicles were placed in environmental chambers and subjected to -20 degrees Fahrenheit. The Kübelwagen's air-cooled engine, designed to avoid radiator freezing, started reliably. German officers nodded with professional satisfaction. Their design philosophy had succeeded here. The American Jeep also started reliably. Its liquid-cooled engine used antifreeze, a solution German engineers considered wasteful and logistically complex. But it worked. The American approach was not elegant engineering. It was effective engineering. Rather than designing engines to avoid the problem of freezing coolant, Americans simply added antifreeze and documented the proper mixture ratios. This pattern repeated throughout the testing. German engineers had developed clever solutions to minimize resource consumption. American engineers had developed straightforward solutions that assumed abundant resources. When resources were truly abundant, the American approach was superior. The question German officers could not answer: would American industrial production actually sustain the material abundance their doctrine assumed? The testing concluded on November 20th, 1943. German officers returned to prisoner of war camps, carrying knowledge that would haunt them through the remaining years of war. They had witnessed not merely superior vehicles, but a superior logistics philosophy. The American military had industrialized warfare completely. Soldiers were interchangeable. Vehicles were interchangeable. Parts were interchangeable. Skills were reduced to documented procedures. Excellence was replaced with systematic adequacy. German military tradition valued the opposite qualities: expert soldiers, sophisticated tactics, innovative improvisation, individual initiative. These values had created the Wehrmacht's remarkable early war victories. But victories achieved through individual excellence could not be sustained indefinitely. Casualties depleted expertise. Germany's limited industrial base could not replace losses at American rates. The Jeep represented this truth in miniature. Yes, the Kübelwagen was cleverer engineering. Yes, it was more efficient per unit of resources consumed. Yes, skilled crews could accomplish remarkable things with it. But American forces did not need clever engineering or maximum efficiency or skilled crews. They needed reliable vehicles that ordinary soldiers could operate effectively using documented procedures. And they had production capacity to deliver these vehicles in unlimited quantities. By late 1943, German officers understood they were losing the war. The Eastern Front consumed men and material at unsustainable rates. Allied bombing disrupted production. Resource shortages forced constant compromise. What the Aberdeen testing revealed was that even if Germany solved these immediate problems, the underlying strategic situation was hopeless. American military doctrine was better suited to industrial warfare. German tactical excellence could not overcome systematic American adequacy multiplied by overwhelming numerical advantage. Part 2. The captured Jeep sitting in the testing facility represented more than automotive engineering. It embodied a complete reimagining of military logistics that German planners had never seriously considered. The vehicle's capabilities seemed almost wasteful by German standards. 800 pounds of payload capacity in a vehicle weighing less than 2,500 pounds, a 60-horsepower engine consuming fuel at rates that made German quartermasters wince. Four-wheel drive, adding complexity and weight that German engineers had deliberately avoided. Yet American forces deployed these vehicles by the hundreds of thousands. By 1944, over 640,000 Jeeps had been manufactured. Germany had produced approximately 50,000 Kübelwagens during the same period. The numerical disparity was staggering, but more troubling than the numbers was what they revealed about American strategic thinking. German military planning assumed scarcity. Fuel would be limited, steel would be rationed, rubber would be precious. Every design decision optimized for resource conservation. The Kübelwagen exemplified this philosophy. Its air-cooled engine eliminated the need for coolant and radiators. Its lightweight construction minimized steel consumption. Its rear-wheel drive reduced mechanical complexity. These were intelligent engineering solutions to real constraints. American planning assumed abundance. Fuel would flow from seemingly unlimited petroleum reserves. Steel would pour from industrial plants operating at capacities Germany could not match. Rubber would arrive from plantations or be synthesized in chemical factories. Design decisions optimized for operational capability rather than resource conservation. The Jeep exemplified this philosophy. Its liquid-cooled engine required antifreeze and radiators, but delivered reliable power. Its heavy construction consumed steel, but provided durability. Its four-wheel drive added complexity, but ensured mobility under all conditions. The German officers examined documentation provided by American testing personnel. Production statistics detailed manufacturing rates that seemed impossible. Willys Overland and Ford together produced over 20,000 Jeeps monthly by mid-1943. Individual. Factories operated 3 shifts continuously. Standardized parts allowed assembly line methods that reduced construction time to mere hours per vehicle. The system prioritized speed and volume over craftsmanship. German vehicle production emphasized quality over quantity. Skilled workers assembled vehicles with attention to detail. Components were inspected individually. Final products underwent extensive testing. This approach produced excellent vehicles, but at rates American mass production exceeded by orders of magnitude. A single American factory could produce more Jeeps in 1 month than German plants produced Kübelwagens in a year. The officers discussed these disparities during evening conversations in their prisoner-of-war quarters. One engineering major who had supervised vehicle procurement for an armored division made calculations that troubled his colleagues. If American forces equipped every infantry platoon with 1 Jeep, and each Jeep could carry 800 pounds of supplies, then a single infantry division with approximately 48 platoons could transport over 19 tons of cargo using only platoon-level vehicles. This did not include company-level trucks, battalion transport, or division supply columns. German infantry divisions relied primarily on horse-drawn wagons for supply transport at company and battalion levels. Horses required feed, rest, and care. They moved at walking pace. They could not operate continuously. A horse-drawn supply column moving ammunition to forward positions might require 12 hours for a journey a jeep completed in 2 hours. The time differential compounded across every supply mission every day throughout the campaign. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The mathematical implications were devastating. American supply systems could execute 6 supply missions in the time German systems required for one. This meant American forces could sustain combat operations at rates impossible for German units to match. Artillery batteries could fire more rounds because ammunition arrived continuously. Infantry units could maintain higher operational tempos because rations and water never ran short. Maintenance depots could keep vehicles operational because spare parts flowed constantly from rear areas. German forces in North Africa had learned these lessons through bitter experience. Field Marshal Erwin Rommel's Afrika Korps had achieved remarkable tactical victories despite chronic supply shortages. Fuel arrived irregularly, ammunition was rationed, spare parts were scarce. Rommel's operational planning was constrained more by logistics than by enemy action. His forces could not exploit tactical victories because supply lines could not support sustained offensives. American forces in the same theater operated differently. When General George Patton's Third Army advanced across France in 1944, fuel consumption was enormous. Patton's tank divisions burned fuel at rates that would have paralyzed German formations. But American supply systems delivered fuel continuously. The Red Ball Express, a dedicated truck convoy system, moved 12,500 tons of supplies daily. Jeeps operating as liaison vehicles coordinated supply movements. Armed jeeps provided convoy security. Modified jeeps served as mobile communication centers. The jeep's versatility troubled German observers as much as its specifications. American units modified jeeps for dozens of specialized roles. Ambulance jeeps evacuated wounded personnel. Radio jeeps provided forward communications. Reconnaissance jeeps equipped with machine guns conducted offensive patrols. Artillery observation jeeps directed fire missions. Wire-laying jeeps established communication lines. Each modification emerged from field necessity rather than formal design processes. German military culture valued standardization and formal procedures. Unauthorized modifications to military equipment violated regulations. Equipment was issued through proper channels and used according to doctrine. Improvisational field modifications suggested inadequate planning or deficient equipment. This mindset created excellent vehicles when properly designed, but prevented the organic adaptation that characterized American operations. The officers examined reports from German units in France describing encounters with armed jeeps. These reports documented growing American tactical aggression enabled by vehicle mobility. Small American patrols operating jeeps equipped with .50 caliber machine guns ranged far ahead of main forces. They engaged German positions aggressively. When faced with superior force, they retreated rapidly and called in artillery or air support. The jeep's speed made pursuit impossible for German units relying on slower vehicles. Operation Grief, Otto Skorzény's special operation during the Battle of the Bulge, demonstrated both German respect for the jeep and fundamental misunderstanding of American logistics. Skorzény's commandos, dressed in American uniforms and driving captured American vehicles including jeeps, attempted to infiltrate American lines and create confusion. The operation required acquiring 100 jeeps for German use. Despite extensive efforts, only 30 jeeps could be found, supplemented by German vehicles painted to resemble American equipment. The scarcity of captured jeeps available for Skorzény's operation revealed the extent to which German forces valued these vehicles. Every captured jeep was immediately pressed into service by the capturing unit. Jeeps were not sent to rear areas for systematic evaluation. They were driven by German officers who recognized their superiority to available German vehicles. Some German divisions argued over possession of captured jeeps while American forces advanced on their positions. Skorzény's operation failed partially because his commandos misunderstood American jeep utilization. German doctrine assumed 4-man crews for light vehicles because the Kübelwagen seated 4. Skorzény's jeeps carried 4 men, which American soldiers recognized as abnormal. Standard American practice assigned 2 or occasionally 3 personnel to jeeps. 4-man crews became identifying markers for German infiltrators. This detail, seemingly minor, demonstrated that technical specifications alone did not convey operational doctrine. German soldiers captured during the Battle of the Bulge reported that American jeeps seemed ubiquitous. They believed, incorrectly, that every American soldier possessed a personal jeep. This perception reflected the enormous disparity in vehicle availability. German infantry battalions might have a handful of Kübelwagens for command and liaison duties. American infantry battalions had dozens of jeeps distributed throughout the organization. The quantitative difference created qualitative changes in operational capability. Winter, 1944–45, brought German forces into direct contact with American logistics on German soil. As Allied forces advanced into Germany, abandoned American equipment littered roadsides. German soldiers salvaged what they could. Jeeps were prize captures. Fuel, spare parts, and ammunition were collected systematically. Even empty ration containers and discarded clothing were scavenged. The abundance of American material contrasted starkly with German shortages. A German soldier, examining an abandoned jeep, found technical manuals stored in the vehicle. These manuals provided maintenance instructions in detail that German technical documentation rarely matched. Step-by-step procedures for engine repair, illustrated parts diagrams, troubleshooting guides organized as decision trees, torque specifications for every fastener. The manuals assumed mechanics possessed minimal training and provided instructions accordingly. A soldier with basic mechanical aptitude could perform complex repairs using only the manual as reference. German maintenance procedures assumed skilled mechanics with comprehensive training. Technical documentation provided overview information and specifications, but expected mechanics to understand systems holistically and diagnose problems through experience. This approach worked well when skilled personnel were available. Combat attrition had depleted skilled mechanics from German units. Replacements often lacked adequate training. American documentation systems compensated for personnel quality variations through systematic procedures. The engineering colonel who had participated in Aberdeen testing compiled observations for a report that would never be officially filed. His notes documented not merely technical specifications, but strategic implications. The American Jeep represented industrial warfare fully realized. Abundance of material compensated for individual skill limitations. Systematic procedures replaced expert judgment. Operational readiness was prioritized over resource conservation. Mass production enabled replacement of losses at rates that made material expendable. His report concluded that German military philosophy, based on tactical excellence and resource efficiency, could not compete against American systematic adequacy, multiplied by overwhelming material superiority. This was not defeatism, this was mathematical reality. German forces could win individual battles through superior tactics and soldier quality, but campaigns required sustained logistics. Strategic success demanded industrial production. In both areas, American advantages were insurmountable given 1944 realities. The Jeep appeared throughout German prisoner of war camps in America. German officers working at agricultural facilities observed American farming operations that employed mechanization at scales impossible in Germany. Tractors, combines, and trucks operated by individual farmers moved harvest volumes that would require dozens of workers in Germany. The agricultural parallels to military logistics were obvious. American productivity per worker exceeded German rates because Americans had tools Germans lacked. At manufacturing facilities where prisoners performed labor, German engineers observed American industrial practices. Assembly lines organized production into sequential specialized tasks. Individual workers performed single operations repeatedly, rather than assembling complete units. Quality control occurred at inspection stations, rather than through craftsman pride. The system produced enormous volumes of standardized products, with workforce skill requirements far lower than German manufacturing demanded. One German officer, an automotive engineer before the war, worked at a facility producing Jeep components. He observed that American workers achieved high productivity not through superior skills but through superior organization. Tasks were simplified to require minimal training. Tools were designed for single purposes. Workstations were arranged to minimize movement. Materials arrived precisely when needed. Completed components moved immediately to the next production stage. The system eliminated inefficiency, but also eliminated craftsmanship. This observation troubled German engineers philosophically. German industrial tradition valued skilled craftsmen who understood their work holistically. A German machinist understood metallurgy, tool design, and measurement principles. An American machine operator needed only to load parts, activate machinery, and remove completed pieces according to procedures. The American approach seemed to reduce workers to interchangeable components in a larger system. But the results were undeniable. American factories produced Jeeps at rates German factories could not approach. The simplified tasks enabled rapid training of new workers. Women and older workers performed jobs that German factories reserved for skilled men. Labor shortages that crippled German production barely affected American output. The systematic organization compensated for skill variations through procedure rather than training. By 1945, German military leadership privately acknowledged defeat was inevitable. The question was not whether Germany would lose, but when and under what conditions. Some officers advocated continued resistance to negotiate better surrender terms. Others recognized that prolonging the war merely increased destruction without changing the outcome. The engineering officers who had examined American Jeeps understood that German military capacity could not match Allied industrial production regardless of tactical prowess. The Jeep became symbolic of larger strategic realities. Its 800-pound payload capacity exceeded mission requirements by design margins German engineers considered wasteful. Its 60-horsepower engine provided power reserves German fuel constraints could never permit. Its four-wheel drive added complexity German resource limitations discouraged. Yet these apparently wasteful design choices created a vehicle that performed reliably under all battlefield conditions, with minimal maintenance and simple operator training. German design philosophy, shaped by resource constraints and engineering tradition, had produced clever solutions to difficult problems. The Kübelwagen was genuinely excellent engineering given its constraints. But excellence within constraints still meant operating within constraints. American design philosophy, enabled by industrial abundance and systematic organization, simply ignored constraints that limited German capabilities. This difference, more than any tactical or operational factor, determined strategic outcomes. The war in Europe concluded on May 8, 1945. German forces surrendered unconditionally. In prisoner of war camps and detention facilities, German officers discussed what had gone wrong. Technical officers who had examined American equipment knew that German military capacity had been overwhelmed by industrial production they could not match. The Jeep, seemingly simple and unremarkable, embodied the systematic American advantages that German tactical excellence could not overcome. Post-war interviews conducted by American military historians documented German perspectives. Wehrmacht generals repeatedly identified the Jeep as among the most impressive Allied equipment, not because it was technologically sophisticated. The Jeep contained no advanced technology unavailable to German engineers. Its superiority stemmed from design philosophy that prioritized operational utility over resource efficiency. American forces could afford heavy, powerful, fuel-consuming vehicles because American industrial capacity supported such choices. The contrast between Kübelwagen and Jeep illustrated broader strategic differences. Germany had fought World War II as a nation mobilizing for total war while constrained by limited resources and industrial capacity. Every military decision reflected these constraints. Vehicle designs minimized resource consumption. Tactics emphasized decisive battles to conserve strength. Strategy sought quick victories before attrition depleted forces. These were rational responses to real limitations. America had fought World War II as a nation with enormous industrial capacity and abundant natural resources. Military decisions reflected these advantages. Vehicle designs prioritized capability over efficiency. Tactics accepted material losses to minimize personnel casualties. Strategy relied on sustained pressure that exhausted enemy capacity for resistance. These approaches succeeded because American production could sustain material consumption indefinitely. The Jeep's legacy extended far beyond World War II. Post-war civilian vehicles adopted features pioneered in military Jeeps. Four-wheel drive became standard for off-road vehicles. Utility vehicles emphasized versatility over specialization. Design priorities shifted toward reliability and ease of maintenance. Modern sport utility vehicles traced direct lineage to the World War II Jeep's design philosophy. Military vehicle development continued patterns established during the war. The Humvee, introduced in the 1980s, essentially scaled up the Jeep concept. Heavier construction provided better protection. More powerful engines supported increased payloads. Advanced suspension systems improved mobility. But the fundamental approach remained unchanged. Build versatile platforms capable of multiple mission roles through field modification rather than specialized purpose-built vehicles. The engineering officers imprisoned in 1943 had witnessed the future of military logistics. Systematic organization would replace individual expertise. Industrial production would determine strategic capability. Material abundance would overcome tactical cleverness. These lessons shaped post-war military development across all nations. The Cold War military competition focused on industrial production capacity as much as weapons technology. Victory would belong to nations that could sustain material consumption, not merely to those with superior equipment. German engineers who examined the Jeep understood they were observing more than a vehicle. They were witnessing a complete military philosophy based on assumptions their nation could not match. American forces could afford to prioritize operational capability over resource efficiency because American industry supported such priorities. German forces, constrained by limited resources and production capacity, could not adopt similar approaches regardless of their theoretical merits. The Jeep's 800 pounds of payload capacity, 60-mile-per-hour top speed, and four-wheel drive represented not engineering superiority but strategic superiority. American military planners could specify such capabilities because American industry could deliver them in quantity. German planners, facing resource constraints and production limitations, were forced to accept compromises that reduced operational effectiveness. The war's outcome was determined more by these industrial realities than by tactical or operational excellence. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.